Hi everyone, I am KHALED ELASHRY, and first I wanted to thank the committee of ASCAAD and also everyone at the Beirut Arab University for the invitation, and I hope you will enjoy the talk for today.
First, a small introduction. I am an associate partner at the London office of Boston Partners, and I'm also teaching at the Bartlett School of Architecture at UCL. Most of the work I'm going to show you today is work done by my team in the office. So first, I'm going to give you a little bit of introduction to the team. I'm part of the Applied R&D team at Foster's, which is a multidisciplinary team of architects, engineers, software developers, mathematicians, and artists. And we aim basically to get the latest technologies in the hand of our architecture designers. We cover multiple topics from complex geometry to performance-driven design to machine learning. And we have done project and initiatives on all of these fields. You name it, we probably have done something related to it. In terms of project, we worked on a wide range of scales, from furniture to yachts to airports to cities. But today, I'm going to show you some cool stuff that we work on. And most of them are kind of outside the realm of traditional architecture. So architects have a great ability to combine creativity and application. And we do that every day in our design process. But actually, whenever architecture meets other disciplines like robotics, biology, engineering, we end up with like truly groundbreaking concepts. So first, I'm going to take you back a little bit to when our office was opened in the 1990s. And then you can see in the picture that there was a lot of drawing boards. Maybe you see a PC or two, but still, obviously, the process was very manual. In the 2000s, you can see more screens, but still a lot more paper, because paper was still the medium that we're using for design. And in the 2010s, you can start to see more screens and less paper. So the design process is always evolving, and we're looking at what's next, basically. As you will see from the presentation, the office have been taking technology very seriously for a long time. So this picture is actually taken 20 years ago. It shows Arthur, which is an augmented reality research project that my group have done with UCL. The hardware you see, I think, cost around 100 pounds sterling per person at that time. And this was like before anything that's commercial was out there for augmented reality. But actually, it allowed us to do full multi-user design and augmented reality. Later on, we began to build our own design tools. This is one of our early performance design tools that's now around, I think, 11 years ago. We're looking at how we can allow designers to make faster decisions where they can basically analyze and get instant feedback for their designs. We're also looking at tools that are in VR and how we can actually do designs in virtual environments. We're also looking at how we can break down the barriers between the physical and the digital. In here, you can see a model being tracked in real time. And actually, we can, on the model itself, we can calculate key metrics like daylight, wind, views, and allowed like an informed decision-making early on in the design process. And of course, as technology evolves, our tools evolve as well. We use gaming engines to build our tool that's called Sandbox that you see here. It's basically Minecraft on steroids, where you can create and analyze various design solutions very quickly without like in multiple interfaces, from like a tablet to VR or to a PC. So we're always looking at how people can collaborate online. And then came the pandemics. And then what you can see here is actually my apartment, where my colleagues Sharif and Zahau were invited virtually into my space in order to do a design review. For us, the office collaboration is very important, and we wanted to keep that spirit going during the pandemic. And so what we've done is actually went and created a virtual version of our physical office. And actually this evolved into our tool that's called the CloudCon. And it's a tool developed by my colleagues, David and Zahau, where basically we can do multi-user digital reviews for our designs. What if actually we want to combine the best of the physical and the best of the digital together? What you see here is an extension of our tool CloudCon, where we basically can augment physical spaces at one-to-one scale. So for example, if we have like on the left a mock-up that was built for the entrance for one of our projects in New York, we can actually go and build a very detailed versions that have all the materiality and so on. And then we can let actually people walk in the actual space, but while seeing the nicely rendered with material and finishes version of the space. And this becomes very important because you get both the scale of the building and also you get the actual finishes that you're going to get in the end. We can take this even further, and what we've done is we build a custom tracking solutions for our tool CloudCon, and this custom tracking allowed us to do this even in the outdoors, which means that we can actually do a much larger scale in the urban realm as well. And how does it work? So basically, you can you calibrate your model to the physical environment, and you can walk and experience the space in VR while you are in the actual space. This allows us to also collaborate with all the other users at the same time, like reviewing, pointing at parts, and discussing different designs. Basically by combining like the tactical experience of the real world and the sounds, temperature, wind, it gives you a very much better virtual experience. And one of the most important parts is a quick comparison, because basically you can remove your headset and then you can see what the actual space looks like, and then you can put your headset and then you can see whatever architecture project you're adding in the space itself. We can also do it as a smaller scale with just our iPads, where it can be an app that people can go and see our building in its location. So back to the physical again, I'll be talking a little bit more about robotics. Robotics have been a passion for me for a long time. I actually did during my master's, my project was trying to get a robot to do bricklaying, and I was always interested in using robotics in construction sites, and this stayed as a passion for me as well afterwards. For the office, also, they have been doing a lot of work in robotics. For example, here is a project for the Moon project, where the idea is to send robots to build inhabitants for astronauts, even before the astronauts arrive to the moon. There was other projects and collaborations for stuff like concrete 3D printing. We're always thinking about how we can integrate robotics as well in the built environment. So what you can see here on the left is Kiva robots, which is the robot that Amazon uses in their warehouses to basically move shelves around. And on the right is what we were thinking, how we can integrate this technology in the outdoor spaces as well for one of our projects. So we're always also looking on how we can use robotics to assist on our on-site processes. And this is one of our latest projects that we have been working on. And it was a collaboration between us and Boston Dynamics, testing the robots on site in London. At the time, we were the only architecture team in the early adopters program, and Spot, the robot, was very popular whenever we take it anywhere. So what did we want to achieve? So as you know, there is the 3D scanning is becoming more popular on site, but basically it's a very manual process where you go and you scan from one point, move to the next, scan again, and it becomes like a repeated process that you need to do. Instead, I wanted to take Spot and basically allow it to start from a specific point on site. And we basically wanted to record a fixed route that Spot can then follow multiple times on a daily basis, that it can go and do the scans automatically. The good thing about Spot is actually it can adapt itself. So for example, if it found a new obstruction, it will actually update its path and avoid that obstruction. And basically during this mission that it can run, it can stop and take scans in different points. And this basically automates the whole process. So we don't need to go and do the scans manually every time. And we have used Spot actually in both construction sites and renovations, and also in our office itself. So for the construction site, we create something called the construction twin. And the idea here is you take a space, and our test bed was the Battersea Power Station project. And it is like the curvy building that you see on the left. And basically we can go and do the scans multiple times for the space, so we can get basically a timeline for how the space is changing. And also using tools like Avir, we can easily find out all the problems that we have on site by comparing the actual scanning of the site with the BIM model. So you can see here a report with all the problems that we can that's happening on site in different parts. I'm going to give you show you a small video that shows the process.
3D laser scanning technology to capture and monitor on-site progress was integrated into a strategic plan developed by our Applied Research and Development Group.
This enables Spot to capture constant, quick and consistent scans of construction sites. This precision monitoring tracks progress while still checking as-built versus as-designed models. Scanning and post-processing times have been reduced from weeks to a matter of days, while freeing up staff resource. Spot's remote control features greatly improve site visit safety and efficiency. Together with its ability to follow a pre-mapped route, Spot provides consistent repeated scans, navigates difficult terrain, and can access hard-to-reach areas on site.
This technology could be used to create four-dimensional models of our buildings, highlighting how they change over time. Combined with data from sensors that read environmental conditions and occupancy, we can create an intricate model of how people, furnishings, and environmental conditions interact. These four-dimensional models could become virtual collaboration spaces, available to people who cannot physically be in the same location.
3D
As we hinted in the video, we can use Spot in also inhabited spaces, basically to also see how the space changed through time. So for example, here, this is one space that's called the hub in our office, and it's our breakout space where we go for coffee or conversations. And we're using Spot basically to take scans of the space daily in order for us to see how people use the space and rearrange it in time. For example, you can see here a comparison between two scans where, for example, one time there was a review. So you can start seeing some boards on the side. You can also see the furniture rearranged differently. So because people move it all the time, you can see some flower vases that have been added. You can also see some of the people that are outside in one of the scans. And this actually feeds in the last project that I'm going to show you today, which is our digital twin project. And for our digital twin, basically, we have a digital copy of our office, and we take a lot of data from sensors like temperature, CO2, occupancy sensors, and basically have build our own digital version of the office. This data allow us to anticipate problems and try to understand people's behavior in the space. And basically this allow us to adapt the space according to the people's behavior. And it also feeds in all our future designs in order to improve them as well when we go into new projects. So this is what I had for you today. I hope you enjoyed it, and thank you again for having me, and please enjoy the rest of the conference.